So that class has the query object method, and object documentation is the same as other AstroPy documentation. It's hosted on Read the Docs and produced by Sphinx, so it all looks approximately the same. Here's another example where now we're querying around a central coordinate with some radius. Same idea, with some extra options when pretty printing. A slightly more sophisticated example, some of these services provide additional features beyond just querying an object and a region around that object. So Simbad, for example, lets you query the, I guess this time we're asking how many publications were made on a particular source over some date range. So with Simbad, you do this add biotable fields thing. But this is now unique to Simbad. No other service is going to support this type of interface. So Astroquery is not entirely uniform. You have to actually dig into the details if you want to get something more out of the service. And usually, I find the best way to learn about these other features is to go onto the website itself and see what services they provide. Then, well, see if Astroquery supports it, or if it doesn't, help Astroquery support that various service. The general use cases we're looking at are, well, first off, downloading data from archives. Because this allows you to, within a single script, download the data, then process it. And it means that you could, in principle, have a pipeline that is, your entire data pipeline could be a single Python script, and you can send that around without actually transferring the data around with it. Now, in practice, I've not seen this fully used yet, but it is possible in principle. So if there's an archive that's hosting your raw data, you can use Astroquery to download it, then run your pipeline on it, and then send that back out. So it's maybe the most efficient way to store reduced data products, because you can spare a few CPU cycles to reduce your data, even if you can't necessarily spare the hard drive space. You can download catalogs. That's kind of the basic feature, but that's the thing that everybody wants, but it's pretty simple. One cool feature that I'll show you is that you can combine the image services that Astroquery is providing with catalog services and make yourself finder charts. And, well, I guess you can superpose catalogs onto images. Now, this is the kind of thing you can probably do with a few other things like Aladdin and DS9 interactively, but you can do this in a scriptable way. And I'd like to hear what other use cases you guys have for this. So one cool utility that I've made, and this is sort of just opening up into a new area here, is combining a few different Astroquery utilities to build, in this case, kind of a finder chart. So in this case, what I've done is grabbed a 2-mass image from the SkyView service. They provide cutouts of various images, and also made a query to the ALMA archive to find out where ALMA has pointed. So they store every single pointing that ALMA has made. And this combines them to show, OK, this is the field of view of existing ALMA observations on what happens to be the Cartwheel galaxy. And you can do this. This is one simple utility. It's a little bit configurable. But I just want to show that this is what you can do by putting the pieces together. And this is using ApplePy to display it. So it's using components from all over the AstroPy ecosystem. So some of the important features, partly from a developer's perspective or from the perspective of people hosting these services. First off, we have a user agent now. So if you guys are unfamiliar with that, whenever you do anything on the internet, you click a link, anything like that, some information is sent from your computer. It includes your operating system. The user agent means usually your web browser, so Firefox, Chrome, whatever, and a few other pieces of metadata go through. With Astroquery, we're now sending the Astroquery name plus a version ID, so just the version you would get by looking at the _version thing, so that the remote services can start tracking how many queries are coming from Astroquery. And this was requested by a few of the remote services, so we have it now. The other really cool feature that I think is, well, it's relatively new, but it's very, very impressive, is the caching. So every query you make from some of these services, they're not all yet on the same footing quite, but they will get cached to this directory. So AstroPy has a great caching system set up, and this will cache any query you make. So if you send, what it's doing is when you send your data payload, so you send the object coordinate plus the radius, it's making a hash out of that information. and whatever result is sent back from the remote system that's what's being stored in the cache, and then it parses that. The parsing happens afterward. So this means that it's caching only the part of sending the data and getting back from the remote system. The part of turning it into an AstroPy table is still going to be done locally each time. But this is something to be aware of, because if you are going to work with a system where you expect data to change on a regular basis, you probably want to disable the caching. So we also have an API that we described about a year ago. I think it's still actually reasonably up to date, but we can discuss whether you think there are any problems with the API or things we should add to it. And there's a template module, which is what I hope will allow you guys to contribute a little bit more. So this is something you should be able to copy, clean it, replace the components, and have your own new module querying some other remote system. The testing components of Astroquery are a little bit different from AstroPy, because we don't want to spam all these services that are hosting the data for us. We don't want to do a denial of service attack on them. So everything, every remote query requires you to pass the remote data tag to actually run the tests that send information to the servers. So what we also have is a set of unit tests that will run locally to test that the parsing works. And so this is we can only test a limited subset of what Astroquery does on Travis, for example. But that is one of the things that I prefer not to accept anything into Astroquery before it has at least some basic unit test, to make sure that there's one example where the data you downloaded from a remote service can be parsed into something in AstroPy. But this turns out to be fairly tedious to do, so I'd be interested in any ideas for streamlining the process of making the tests. So the template module looks something vaguely like this, where I've chopped out all of the important comments. If you want to create a new module, you want to query a service that's not currently supported, you'll use this template module, which basically looks something like this. There's this little magic decorator up here. You don't really need to know too much about what that does, but I'll give you details perhaps if we go to the afternoon session. Every service has a URL where you're sending the query, which is an AstroPy configuration item, because some of these have mirrors, and so we would like those to be configurable, so you can set up which mirror you prefer to use. And there's a timeout, so if the service doesn't respond in 30 or 60 seconds, you give up. But basically, these few lines are what a query would look like. You just build yourself a payload, which is a dictionary, and then you send it to the remote service. Then the next very important step is you have to have some way to parse whatever this response is, but that completely depends on what the service is giving you. So for creating a new Astroquery module, the process can differ quite a bit depending on how nice the service is that you're talking to. In the best case, they will have a well-documented API, and you can just use that their API to say exactly what Astroquery should be doing. In the worst or most common case, somebody has written up their own homegrown CGI, and they'll let you put in the RA and DEC as long as they're space separated in RA and colon separated in DEC with 3 spaces between them, things like that. This is actually fairly, well, okay, that awful case doesn't happen too much, but there are a lot of various things out there that support only a very limited interface. And so usually for those, we have to do web scraping, which is not a highly respected phrase in the computing community, but partly because with web scraping, you never know if the internet's going to change under you after a month, a year, or 10 years. In astronomy, we have the luxury that actually most people don't change their web servers for 1, 5, or 10 years. So yeah, we get a little good, little bad. So the usual process for this is that I use either the Chrome or Firefox Inspector. This is a built-in developer tool in these browsers, or you can use these web developer plugins, and then you can inspect, see exactly what the name of the variable is they're sending to represent an object or radius or whatever. All right, so I'm going to talk a little bit, I'm going a little scattershot here, but I want to tell you about the relationship between Astroquery and some other projects. So we decided a while ago that Astroquery is, even though it's an affiliated project, it's never going to be merged into AstroPy because we can't really rely on the remote services staying the same from day to day. So Astroquery has to be able to move very, very quickly, and that's not really what we want in AstroPy. We want stability in AstroPy. So there's a reason to keep these two separate. For this same reason, the development version of Astroquery is almost always going to be the best to use. There's almost no reason to use a version even one out of date because many of these commits will be just responses to changes remotely that we can't control. Also, Astroquery is not the VO. It's not meant to replace the VO or anything like that. I don't really fully know the relation there, but Astroquery is really just, it's the hacked way to deal with interfaces that people have made that are not VO compliant. Maybe it can also work with VO compliant things. There's no reason not to, but it's really meant to be the workaround for when services have not given you a nice interface to work with. So the future of Astroquery, I would like to see all of these things. I would like to see more modules, more interfaces to things like the Hubble Archive, MAST, the Canadian Archive Data Center. A few of these things, there's some really big archive services that we just haven't gotten around to implementing the service Astroquery for. Same with Ursa, has a really beautiful imaging setup. Yes, that's another. Actually, there might even be an open pull request for that. Yeah, so there are a few of these. We would like to get them going, but don't exist yet, and that's really just a lack of labor. Partly because I haven't yet had to use any of those for my science directly. Usually that's the motivator for one of these to get written. But so I would like today to, well, I've written on the board for the first session, I'd like to have an Astroquery unconference session, which will hopefully be a little bit of pair coding and me showing you how to contribute and you telling me where things are confusing or what is hard to do. So I'd like to do all these things. But briefly, I'm going to walk you through the process of creating a new module. So from the perspective of inspecting a website, so this is the ESO archive. This is actually their front page. We have an ESO archive querying thing, but it's actually only for the instrument-specific forms, not this generic thing, which is, you just, for this one, all you have to do is put in an RA and DEC, and you can press search. And there are like 50,000 other options, but you don't have to put in any of them. So the basic way I would go, they don't have a public API for this, but they do promise that their API will be stable because I asked them.
What do you do with these 50,000 options? Are they all payloadable?
Yes, we'll get to that in a sec. But for the basic options, the RA, DEC, and radius, which are really the things that every query kind of needs, in this case, I used the Firefox web developer tool and turned on the form thing. So now you can see for each of these things, this red stuff is showing the name and of the input. So the names here.
What's the name? Firefox web developer.
Yeah, it's a web developer plugin. There's one for Firefox. There's one for Chrome. If you just Google that.
It's called Form something. Form.
So the web developer plugin is the software, and once you have that loaded, there's a forms menu. I can show you that later. And interestingly enough, I was shown this by one of the people working on on the ALMA archive, because they have to do this for their own, when they're making their own query tools. They do this kind of thing all the time. But anyway, I'll show you some details later. But basically you're grabbing the information here. These give you the keys for your payload dictionary, and then the values are whatever the values need to be. So you'd have a dictionary with RA equals RA and DEC equals DEC. And everything else is optional. Oh, I did actually zoom into this. Good. So the way you would actually make this kind of query is we have a tool in Astroquery called parse coordinates. It's in this utilities module. And what this will do is take an AstroPy coordinate, a string, which could be an RA-DEC string, or it could be an object name, and it will try to turn that into a coordinate. And it tries, I think the first thing it'll try is using the Sesame parser, treating it as if it was an object name. Then it'll treat it as if it were a coordinate. And it'll try a few things. So this is sort of the generic parse everything approach. Then your payload, as I said, is a dictionary. You just give it RA-DEC, and you're giving it the unitless values. You're not passing quantities to the remote service. You're just passing floats. Or in some cases, you actually need to pass the sexagesimal code. In this case, I'm giving it hour and degree. Some services want degree and degree. These are the things that we try to take care of in Astroquery, so as a user, you don't have to pay attention. Ideally, okay, for the rest of the arguments, the other 100 options, you just pass them on as keyword arguments. And if you're really nice or really capable, you try to validate those and make sure that they're all valid keywords. If you want something that just works for now and will get you somewhere, you just pass it all on and hope it returns something nice. Now, admittedly, that's not the best way to do things, but in some cases, it's the only option. There are a few services, like the Alma Archive is one of them, that will actually do the validation for you. So you send them a payload, and they'll tell you if you've given them any invalid keywords. Most services, unfortunately, do not provide that for us. Then the last step is you send the request. So this request module here is, it uses the Python request module, which is a really great module for any kind of web interaction. It's much better than URL-lib for just about everything, so use that if you can. But this is our custom request module, which does the caching as well. So that's this little argument here. It deals with timeouts. The payload is just a payload, and the URL is there. You can have get or post. I don't think there's really anything else that goes there. And then the most important part is whatever content you get back, you need to parse into an AstroPy table, which may mean parsing it as a VO table. And that is completely dependent on what the service is returning for you. This bytes.io thing is the stuff where I get really confused because this is needed for compatibility between Python 2 and Python 3. So Astroquery will work with both Python 2 and Python 3, but that was the biggest headache in the world. Yes. Yeah, you don't need to see this. The last thing I want to bring up as a possibility here is I think it would be a good idea to have a publication on Astroquery now. I'm aware of a number of people using Astroquery in day-to-day work, but it's only shown up in a total of, I think, 3 publications so far. And it kind of makes sense. Astroquery is kind of the first thing you go to before you actually do the real work. So by the time you're writing a paper, you may have forgotten that you were using it at some point. And also, you should be citing the services that provided the data in the first place. That's even more important than Astroquery. Astroquery is the glue between you and the remote service. So I would like to hear feedback from you guys if you think there's anything. Well, this would be, if we went ahead with this would be the second AstroPy-based publication. So I'd like to hear feedback from people involved in that and whether you think, in general, this is a good idea, or even what journal we should submit to. So yeah, with that, if you have any questions, please ask. Otherwise, we'll try to do an unconference session if people sign up.
One or two quick questions?
So the publication that you just mentioned, does Astroquery currently make it easy for you to say, put me out a bit of tech, like not necessarily for Astroquery, but from the services that you're using, I can just paste?
No, that's actually a great idea. This is something we had discussed in other contexts, but I think you're right. For each module, it would be really great if there was just module.bibtech. Yeah.
These footnotes where it says this service or this paper I use of, I don't know.
Yeah, we should absolutely do that. That's a great idea.
I was going to say, on top of that, like there's some great functionality already in another language that who starts with something near S where they have a dot citation that you can just ask for and it comes out. We should definitely do that. It's easy for us.
Yeah.
Tom started working on like a web form citation generator thing that you can plug extra services into. I think we've got various data archives and different software and stuff. So you sort of go, I've used this, and this in this paper, press go, and it gives you a BibTeX citation.
So maybe we need to create a query service that goes to that. Fetch the
Which Tom are we talking about?
R.
Rover, yeah.
So we should definitely talk about this later, but we've just been talking about for the core package developing some sort of decorator that you can put around functions or classes.
Ah.
But then at the end you ask, give me all of the citations I should use. So that if in one Python session, you access like 5 services, you just ask, what are all the citations and it prints them out and do it.
Well, so that should probably end up in AstroPy helpers.
Yeah, exactly. Absolutely.
Well, some of them get actual citations, some go in the acknowledgments. So.
We would have to tell you which of those.
So, first of all, Astroquery is awesome. Thank you. Second, I'm curious, so though, the AstroPy paper, even though I have to be honest, I haven't read it, is presenting like some new implementation of a thing which astronomy hasn't necessarily seen before. It's sort of like a method paper for the collaboration and everything. I'm curious. I think it's worth thinking about what the goal is of the publication, right? Is it just to get the metrics so that you get the credit, or is it actually like a new method which is, is worthy of a paper publication? Hold on, let me find it. And then the other thing to think about is, which is relevant for all of us, which is that I think it might be rather than trying to take our new, it's not ours, nor is it new, this particular coding contribution and trying to slam it into the paper citation reference thing. I think we would be really well served by thinking about ways in which we want our contributions to be cited and recognized, and instead of having in addition to having our H-index on our CVs, which is how often we publish and how often we're cited, but to also have our GitHub, to start putting lead authorship and co-authorship contributions on modules and packages, and then relevant metrics like these for how often those packages are used. Do you see what I'm saying?
Yeah, well, so short answer first, this is the kind of conversation that I did want to bring up with this a little bit. I would like to know, I think this probably would go to a computing journal, not to an astronomy one. There's nothing new in Astroquery. It just implements known things. Sorry, they're the astro computing journals, I think, that actually would possibly consider this. On the other hand, though, I think what I would really like out of a publication is publicity to the mainstream, basically. I want to put something on arXiv that says this is where you can go to find command line, Python command line tools for accessing all the services